some sort of eclipse happens about every 6 months, and a total eclipse happens every about 18 months. So this is one of the big drivers for astronomy as a science happening at all in the history of the world. But in ancient China, there were 2 astronomers that failed to predict a solar eclipse. Do you know what happened to them? Yeah, they didn't make it. But it's very interesting because they described it as the dragon was eating the sun, which I think is a really wonderful visual of like what an eclipse looks like.
So, and I think the real benefit of this program is you'll all watch the eclipse. We will have 61% of totality in New England, which isn't 100%, but I think it's still going to be great. And we will have crews in Salem, Oregon, in Casper, Wyoming, and also at NASA in Houston, where they're flying 2 jets from Houston over Illinois, and they will have a combined total of 7 minutes of totality. So I think we'll get a lot of great stuff. Then we will be integrating that into the show that we already have made, which will really give you a lot of information behind the eclipse, because while it's a fantastic viewing experience and it's all hope for good weather, scientists are also going to learn about our local star, which is the sun and the source of all life on Earth. And they'll be learning. The interesting thing is, the fascinating thing, and it's kind of an enigma, is why the corona, which is the sun's atmosphere, is actually hotter than the surface of the sun itself. Additionally, they'll be learning about more about how to predict solar storms, which are emitted from the sun with electromagnetic radiation and can easily bring down the grid and all forms of communication. So we need to really learn. We're so dependent on our electronics. We really need to learn more about those. So thanks very much. Set your DVRs, tell all your friends and relations, and I'm going to turn it back over to Daryl.
Thanks, Paula. All right, well, thank you, Paula, and thank you, Michael, for joining us today. And without further ado, I'd like to introduce Janine, a digital content strategist at Sky and Telescope.
Hello. Thank you, everybody, for coming out here. Ooh, feedback. If I keep talking, maybe it'll go away. Sorry. Is it you? Is it you? Did you forget to turn something off? All right. My name is Janine Myszka. I am the digital content strategist for Sky and Telescope magazine, your one-stop shop for all your eclipse needs, except for, watching the wonderful NOVA program. So, right. So my background is in science communication. I have a master's from Imperial College London, and I last worked at the Orlando Science Center. So if I sound like I'm talking to 5-year-olds, that's why. Please ask any questions as you're going along, as you think of them. I want this to be really interactive. I'm going to try really hard. If I forget something or sound silly, just call me out. That sounds great, right? Okay. So the title of this talk is An Eclipse for Everyone. That's because even if you're not in totality, everyone in the entire United States, Alaska and Hawaii included, is going to be able to see a partial eclipse. So that's going to be really cool. Okay. So first, let's look at pictures. Ooh. Ooh, this is Easter Island in 2010. This photo is taken by Dennis DeChico, who is a contributing editor at Sky and Telescope. This one is from a space station in 1999. I got this beautiful one. I don't know where it's from, but it's from March 2016, so last year. I like this one because it shows you like all the parts of the eclipse. That's good. Okay, what's an eclipse? Anybody know? No. Yes, good. Answering questions. I like it.
I believe it's a blocking of the sun.
A blocking of the sun. Okay. Okay, that's a good definition of it. So there's actually 3 kinds of eclipse. So 2 of those kinds are a blocking of the sun, well, from the Earth, right? And one of them is a blocking of the sun from the moon. So we've got a total eclipse. That's what's happening this coming Monday on August 21st. Exciting. But you can also have an annular eclipse. So that's when not the whole disk of the sun is covered. And then a lunar eclipse, which is not to be confused with the phases of the moon, like on my t-shirt, that are out of order. By the way, I don't, Target, what were you thinking? But not to be confused with the lunar eclipse, fun fact, as a child, not that much of a child, when I was in college, freshman year in college, studying astronomy and astrophysics at Villanova University, I looked up at the moon and I said, aha, look at that shadow of the Earth on the moon. Was it the shadow of the Earth on the moon, guys? No, I was looking at the night on the moon. But when the shadow of the Earth is on the moon, then you get a lunar eclipse. And lunar eclipses are really cool because lots more people can see them. So actually, here's a fun question. How many of you have seen a lunar eclipse? Yes, good. How many of you have seen a solar eclipse? See, fewer people, right? Because it's harder, or you have to be in a more specific place on the Earth to be able to see a solar eclipse. Okay, why does it happen? And is the Earth special? Yes, the Earth is special. We live here. All right, any guesses? What does this represent? The moon, that's a good guess. Anyone else? The sun? Ah, there we go, the Earth. Okay, so this represents the Earth. If this is the Earth, what is this? The moon, absolutely. Okay, now I want you guys to guess. You can point at things in the room. How far away do you think in the scale, this is a roughly scale model, how far away do you think the moon is from the Earth?
Cambridge.
Cambridge, closer. It's in this room. Anybody over there want to like stand up if you think you're close? I'm looking at the one in the Hawaiian shirt because you're about where the moon is from the Earth. So that's pretty far away, right? In that same scale model, the sun would be about 1.5 miles away. I did the math. 1.74 miles away. So that's a big difference in scale between Earth and moon, but still far away, right, that the moon is that far away. Okay, so why does it happen? Is the Earth special? If you had the sun 1 mile and 1.73 miles away, and the moon there, they would be about the same size in the sky. So don't do this with your unsafe eyes, but you can do it with your cool eclipse glasses that you're getting. You can look up at the sun and you can kind of hold up your finger and see how much of the sky it actually takes up. You're like used to thinking that it's this huge thing, but actually it only takes up about a fingernail's width of the sky, which is actually about the same amount the moon takes up. So from the Earth, the moon and the sun are about the same size. So that is special. I forget what my next slide is. Great, good. So as the moon goes around the Earth, it's going in a nice ellipse, not a perfect circle, right? But we're used to thinking about the solar system as kind of this plane, this nice flat pancake, like you spun out a pizza for your crust for your pizza, but it's not like that. Different parts of the objects are going around at actually different angles. So the amount that the moon is tilted as it goes around the sun, goes around the Earth, not the sun. Well, it does go around the sun, but it goes around the Earth first. As it goes around, is about 5 degrees with respect to how the Earth goes around the sun. So the Earth and the moon and the sun can all line up when they're at that point. So if you look here, there's kind of, if you look at, you can see that the green is tilted, that's the Earth, or the moon going around the Earth, and then the red is the Earth going around the sun. So there's a couple different places here. Right, okay, so when can a solar eclipse happen? What phase of the moon does it have to be in for us to have a solar eclipse? Any guesses? Okay, so if it's a full moon, then we are seeing the daytime or the nighttime of the moon. Daytime, right? Because it's completely covered in sunlight. Okay, but in eclipse, what side of the moon are we seeing? The dark side, the nighttime side. Okay, so it's not the full moon, so it's the opposite one. It's the new moon, right? So when the new moon happens is when you can have a solar eclipse, but it doesn't happen every single time because when it's going around, it's tilted, so it doesn't always line up on that same plane. Good, good. Right, where was I? Okay, so it's not in the same plane. So about every 6 months, it lines up so that it is sort of in the same plane, so there is a partial eclipse. But every 18 months, it lines up more or less so that there is a total eclipse. Okay, and those points where it intersects the planes are called nodes. fancy science words, right? Okay, some more geometry. So, the blue line says orbit of the Earth. I think everything else is pretty easy to see. So, the moon is going around the Earth like this, and the Earth is going around also like that. And as it's going around, at some point during the new moon, sometimes, it passes between the sun and the Earth. And if you look at this, you'll see that there are two parts of the shadow. So we here in Boston are only going to be able to see a partial eclipse. That means we're in what's called the penumbra of the eclipse, which basically just means that the shadow isn't completely dark. And the umbra is the perfect sweet spot of where all of the sun completely will be blocked. So if you walk away with any two eclipse words that you want to sound fancy, be like, I'm going to be in the penumbra of the eclipse, or I'm traveling and I brought lots of water, and I'm going to be in the umbra of the eclipse. I hope you also brought toilet paper. Okay, so what can you see from here, from Boston? What did I say? Anybody remember? Penumbra in a partial eclipse. Yeah, so it depends which kind of, oh, that's terrible. So I've got screenshots here from a widget that we have on our website, courtesy of, no, I can't read that either. But they made it, and it says it there. Wait, Sky Safari 5. So they made us this really nice widget, but you can't quite see where the sun is in it. So you can see, depending on how you measure the amount of the sun you're seeing, you either are seeing something like a 63%, or you also see 61%. But it's going to start for us here, the partial eclipse, at 1:28. It'll be at its maximum coverage at 2:46, and then it's going to end just before 4 o'clock at 3:59. And you can see where we are is very far away from that nice line of the eclipse. Everybody else I work with, they're going to be in the line, not me. I'm the new one. Yes, okay. So yes, we're going to see a partial eclipse. If you could see these, they would show you how much of it, but it's about 63% of the sun will be covered by the moon. Where is the eclipse visible? So this is actually, I really, really like this chart. So hopefully you can find somewhere to look at it. So this is the path of the entirety of the eclipse. And there's this really nice diagram of the United States, which I forget who it's from. We didn't do it. But it shows you the path of totality and then maximum amount of coverage across the entire United States. So that's a really cool one. The other one shows you where and when that eclipse is happening. So you've got it, it does start, you can find Hawaii is right next to the E where it says eclipse begins at sunrise. And then you've got Alaska, goes across the entire United States. One of the big reasons we're talking about, wow, this is a really big deal, is the last time something happened like this was in 1918, which was before the end of World War I. It was just about to be the end of World War I. It is crazy to think about that that's what the world was like the last time we had a coast-to-coast eclipse. Okay, here's a good picture of what it'll look like. 63% here. Now, I forget if I said this, but the last place I worked and recently moved from is in Orlando. You can see I made a great choice about how much of the sun I can see. So I have an 85%, but we'll be able to see a pretty decent amount. It's definitely worth looking at. How do I view it? That's what you guys are all here for, right? The free Eclipse glasses. Yeah, so safety first. Their number one thing, just like any other time ever, don't look at the sun. We here are not lucky enough to have totality, so at no point during the solar eclipse will it be safe to look at the sun. This is just not good. Unless you have a nice, safe way of doing it. So there are a couple different ways. One of them is Eclipse glasses. These are the ones we have at Sky and Telescope, but you guys all got lovely ones from Nova. Thanks, Nova. You can also make some sort of a projection viewer. So yeah, you were all wondering, what's the cereal box for? So this is a really easy one. You cut a hole in one side, you cut a hole in the other side, put some tin foil over it and poke a hole in it, just a pinhole projector. If you put a white on the back, if you put white paper on the back, it'll make it easier to see. And if you paint the inside black and then put the white paper, then you're like super fancy.
Can't put that away yet. So where's the pinhole?
Pinholes here in the tinfoil. You're looking in here. So like this. Ooh, I can see it. It's really good. Right.
And what will you see on the inside of the box?
So if you look up here, I've got a couple different pictures of different types of projection. So you'd see the same sort of thing as she's seeing with the tube over her. And this is a pinhole projector. If you think about a pinhole camera, it blocks out a lot of the other light and only lets certain light in, and that lets you have a nice clear image. It's going to be a smaller image. But you can also use like a cool mirror. I like that one a lot, the upper right-hand one. So she's got like a dental mirror, and she's projecting onto a white thing further away, because the closer you are to your hole, the smaller it's going to be. If you think about shadow puppets, right? The closer you are to the thing you're projecting on, the smaller your hand is, but the closer you are to the source, the bigger it is. So you want further distance between the two. And here we've got binoculars. If you do with binoculars, don't let anyone go in between the two and try to look through the binoculars. You can also like put a piece of cardboard around that, and it'll make it so you're blocking out more and you can see the image more easily. I'm not sure if I have, no, okay. So there's also, if you're like having fun with kiddos, you've got kids at home, you can draw a picture and then kind of like a constellation. Maybe I'll pass this around so you guys can see it up close. But basically what I did is I drew a picture of a cat, which you totally can't see in the cameras, I'm sorry. And then I went around the whole outline and poked holes in it. So I made lots and lots of holes. This has one hole with my cool cereal box projector. But you can make lots and lots of holes, and then the projected image will be multiple projections. So you'll have like a whole shape of whatever you made. This is actually from Emily Laktawala. I think that's how you pronounce her name. And she did one with Totoro. It's really cute. She's got a nice picture of it. But so it'll make lots and lots of projected images. But if you're like, oh no, the eclipse is happening. I forgot to make a projector. I don't know where my eclipse glasses are. Got your hands, right? So you're gonna put your hands like this, and you're gonna make really small holes with them. And actually those really small holes can act like pinholes, and you'll be able to project just as easily that way. Whenever you're doing a projection, you're gonna want to stand with your back to the sun and make your shadow as small as possible. Now don't block the thing that you're trying to put the light through, because then you've got no picture of the sun, because it's just your shadow. You eclipse the eclipse. But so you're gonna wanna stand away from it, make this a total eclipse of the sun. It's good, it's good. So you wanna hold it so that you can see it, project onto something white if possible. That makes it a lot easier, but you can project on other ones as well. If you have one of those cool mail tubes that you can get from like Staples, if you cut the end of it, you get a nice white cap, so that's set with your projector, and then you do similar to this, where you put tinfoil or some sort of paper along the other end where there's the hole. So you take the cap off of it, so there's a hole. And then you just put one pinhole in it, and then it'll project onto the lid. So if you have one of those hanging around at home, if you've got wrapping paper tubes, you can do it with that too. The nice thing about doing that is that you're stopping light from the outside getting into that image. So it's the same kind of basic principle as a telescope, sort of, without lenses. Okay, when is the next one? Anybody know? 2024, that's the one we care about. There is one before then, there's one in Chile. The one in 2024 is gonna be, oh, so here's the one in Chile, also Argentina. That's the one that kind of goes like swoop along the bottom of South America, where Chile and Argentina are. But the United States is gonna be April 8th, 2024. It's gonna go Texas to Maine. So it's gonna be so much easier for us to get to. I'm holding out hope for that one. You could shuffle off to Buffalo.
So we'll get like
and watch
90%?
It. Yeah, you get 100%, yeah. Oh, us here. Yeah, probably like 80, 85. That's a good question.
I'm not going to.
No, it's not too far. But you could go 15 miles on the Erie Canal. No, I'm from Buffalo, guys. I'm sorry. Okay. Oh no, we got some good stuff there, but I did move away, so there's that. That's what I have to talk about, but I would love to answer any questions anybody has. So, also, for more eclipse resources, visit skyandtelescope.com/total-solar eclipse. It's August 2017. I made the pretty picture there, so you should check it out. We've got loads of resources there. We link to all different things. Nova, of course, has wonderful things on their website as well. But questions? And she's got a microphone, so she's going to run it to you so that they can hear. Right there in the middle.
This is working.
Oh, that's there. He's just like hanging out in the back, hiding the sound.
Sorry, I'm going to interrupt this.
We interrupt your selfie? Not a selfie. Oh, you're taking a picture. I think the slideshow will be available online afterwards also, by the way.
Because I won't remember.
Yeah, if you go to skyandtelescope.com, it's what you click on that says Total Solar Eclipse. It takes you to that page. It's our whole portal. All right, your question.
So the video that you were showing earlier about how to protect your eyes said that if you're using binoculars or a telescope, you need to put a filter on the outside.
Yes.
If you have that filter on the outside,
Yes.
do you also need eclipse glasses
No.
to look through?
No. That's a really good question. And actually, there's different kinds of filters too. So you might have like a nice welding filter. You might have a nice mylar filter. You could be really cool and have a hydrogen alpha filter and everything's red. But yeah, you want it at the part where all of the light is coming from because you want to get it reduced before you're focusing it, right? Don't do what I did with some friends freshman year in college with the telescope and see if you can set paper on fire. You can burn a hole through paper, if you were wondering. You can. It's a thing. Ooh, a question. Excellent.
I don't think we're long. Oh, we are.
You are. You got lots of coil.
What happens to your solar panels during an eclipse?
Oh my goodness, that is such a good question. So, solar panels work by the sun hitting them, right, and releasing or creating energy through that. So during a solar eclipse, they'll just make a little bit less. If you were in a total part of it, there'd be like probably maybe like 5% of the amount of energy it would normally make because it doesn't get completely dark. It gets like twilight dark. But here you maybe would only like notice like 20% less that you're making. But that's a really good question. I love that. Yes.
All right. Oh, sorry. We have a question from
online.
Facebook from Jennifer.
Jennifer.
She
Hi,
asked,
Jennifer.
why can I watch the sunrise but not the eclipse?
Why can you watch the sunrise but not the eclipse? Well, I'm not sure where you are, so that's a good question. But if you can't see totality, it's because you not only have to be able to see the sun when it's happening, but you have to see when the moon is hitting the sun. And so the Earth is spinning, and then the moon is going around us, and then the sun is over there, right? So it only happens when the sun kind of the moon starts being in the way in terms of geometry. So everybody in the whole world that day is going to be able to see a sunrise because, well, unless it's cloudy.
I think,
Doesn't she mean like no? She
I think she means
in general. You know how why can you watch? You can look at a sunrise.
Yeah. Okay. So that's a good question. Okay. So if you are asking why can you look at a sunrise and not look directly at, thank you, that was a very good interpretation. If you are asking why can you look at a sunrise and not look at an eclipse directly, it's because of where the sun is with relationship to the Earth. So the sunlight that you're getting during a sunrise or a sunset is much more at an angle. You're getting direct sunlight during an eclipse. So I think that probably has to do with it. A lot of times when you're looking at the sunset, you're like catching it at the very end because that's when it gets pretty. So you're not looking at it when it's the whole disk of it. So that's part of it. So I would say probably it's that it's bent and that you're only seeing a very small part of the sun.
all right. Oh, sorry.
She's going to run over the mic to
I'm
you.
going to try to run as fast as I can, Niels.
Hi. I have a question about the prominences.
Prominences? Mhm.
Yeah, do you have any idea how the prominences will look this eclipse compared to other eclipses?
That's a really great question. So there are predictions already for that, and we wrote an article up on skyandtelescope.com if you want to look it up. We won't be able to see them here, but in totality, they're going to be able to see what's called the corona of the sun. That's the part of the sun she was talking about during her introduction. It's the part of the sun that's all of the plasma spiraling around the magnetosphere of the sun, and it's kind of hairy looking. So we do have predictions of what it should look like. If you search like predicted coronal appearance or how will the corona look during the eclipse, we have predictions based on what the solar activity, magnetic activity was like one solar rotation before the eclipse. So it should be good, but not like super active. We haven't had a lot of sunspots recently. We haven't had a lot of activity. We're headed towards solar minima, right? So you've got your 11-year sunspot cycle, and we're headed into the low part of it. So pictures online. Yes.
Question up front.
So if I hadn't been at this show and I had no idea that this was happening, I'm sitting in my backyard on the 21st, 1:30, and drinking my mint julep, I would witness something, right? I would know that something's going on up there.
So it depends where you are. Here, it'll be like a little bit different, but not because less of the sun is being covered, right? One of the things that has been explained to me is that shadows get sharper looking, so that you might notice that. It will be a little bit dimmer, but we're only at 63%, so not that markedly. Yeah, maybe like a little bit of cloud cover. But the thing is the shadows get sharper because you're getting less rays coming at you. So it's a clearer line. So that's a thing to look out for. But we'll see.
Question on the other side.
I should say that the last time I saw a solar eclipse, I was like 4 years old, and I'm like in the parking lot at the local grocery store being told not to look at the sun. So that's what I remember of the last one. Okay, I see you. Okay, question.
Hi, I remember at one point when I was a kid walking along during a solar eclipse. Obviously, it wasn't totality. But when I looked at the shadows on the ground, all the leaves had a crescent shape.
Yes, so that same thing that I was saying that you can do with your fingers, trees also do that. They make little pinholes. So if you look at the shadows of the leaves on the ground, you can see multiple of the eclipses projected there the same way. Yes, very cool. Excellent observation. I have a friend over here who is.
Wow, you guys are really making me work for it.
Oh no, it's trapped. You're good. You're good.
Haven't tripped yet.
I saved you.
If animals look at the solar eclipse, what happens to their eyes?
Oh, if animals look at the solar eclipse, what happens to their eyes? That's a really good question. So, a lot of animals just think it's nighttime. So if they're in totality, they go, like the birds will go to roost, and like sometimes the bats will come out because they'll think it's nighttime. But that won't happen here. But animals are pretty good in general at not looking at the sun, so they don't have any reason to think they should look at it. But that's a really good question. They're very safe. If you want to put eclipse glasses on your dog, though, you totally can. Yes. That is such a good question, and I should have talked about this more during the Is the Earth Special portion of my talk. Do other planets see eclipses? So, no, sort of. Okay, so they don't see total eclipses. So the reason the Earth is special is that the moon, remember, is about the same size in the sky as the sun. So that's the only way we can get a total eclipse, is if they're the same size. So with other planets, they might have their moons going in front of the sun, but they wouldn't be total eclipses. They'd just be like partial ones, little ones. On Earth, we sometimes get annular eclipses because the moon actually is in an ellipse, so like an oval, not a circle around the Earth. So sometimes it is a little bit closer. So when it lines up along that line where the moon's orbit intersects with the Earth's orbit around the sun, and it's closer to us, you'll have a ring around the outside. Actually, I can go back to that in the slides. Dun, 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 dun. There it is. Okay, that bottom left picture where you've got the ring around it, that's a non-total eclipse. But that's a really good question.
And then I think we had a question up front. Sorry, I'm just going to travel this way.
Dun, dun, dun.
Thank you. And on the question from the previous question.
Yes.
About animals.
Yes.
What effect does this have on the environment for the 7 or 8 minutes here in the continental U.S.?
Can you be more specific?
No.
Okay.
That's your job.
That's my job. I will do my best to
Wing
interpret
it.
your question then. So we probably won't notice too much difference here in Boston. Along the path of totality, the temperature will drop during that time, but it's not any more than it drops overnight. So it will be cooler. The clouds will sometimes come in because it has suddenly dropped in temperature, so you get clouds to form. I'm trying to remember if I've heard about other things. I've read so many articles. Those are the two things that I think I've heard about. But if you have more questions about it, check out our Eclipse portal. Read all of our articles. And you can tweet at me at Sky and Telescope, and is spelled out, or message us on Facebook, and I can get more answers for you. I think she's got the mic.
Hi, I was just wondering if you can expand on what scientists in NASA are looking for.
Oh, great question. Okay, so I didn't talk anything about what the cool sciences are that they're doing during this eclipse. There are a bunch of different projects going on. One of the things that we're really excited about is, if you look up, it's called Eclipse Mega Movie, but basically they're trying to get the corona of the sun, that wispy part, studied for the entire time it goes across the entire United States. And actually people just like you are going to be able to contribute to it. They just download an app on their iPhones or other smartphones. You can see what kind of phone I have. You just download the app on your phone and you take a picture of it, and they'll put that together along with some observations done with telescopes along the route by people who are trained with them. And that will give us the longest and best observation of what the corona is like. And they're trying to figure out this portion of the corona that is kind of between where our spacecraft that takes data about the sun is and Earth. So we're trying to find out about more of that part. There's a balloon project that's doing some really cool stuff. I think that's Citizen Kate. Oh, I'm really sorry if I got that wrong. But that's happening. We've got several things from space that are observing it. The guys and girls in the space station are going to be able to see the eclipse from space. There's going to be a couple planes that are going over to take data. So there's going to be lots and lots of awesome science that's going on, and you'll be able to see that afterwards. I don't know if you're talking about that at all.
And you can watch it on Nova's Eclipse Over America at 9 p.m. on Monday night.
There you go, nice plug.
Yes, hi. I'm going to Wyoming on Thursday. Hopefully the weather's good. What planets would I see during the eclipse?
What planets?
I know. Do you know? You can see planets, but I don't. You know.
Yeah, I don't remember. I think Regulus is the star that I keep seeing. There are charts on our website that have what you'll be able to see during totality in the sky, because it gets dark enough, it's kind of twilighty, that you can see stars and planets in the path of totality. But I don't remember if there's any planets that are on those charts. But go there, and it will have the answer.
We're back over here.
Yes, oh my goodness, you have so many good questions.
How do people know when a solar eclipse is going to happen?
Oh my goodness. Okay, this is a really good question. So we know how long it takes the moon to go around the Earth. We know how long it takes the Earth to go around the sun. We know what the angle is that the moon is tilted with respect to the Earth, and we know what that plane is. So we can put it into a computer. We can write all these formulas for it, and then it can project over time. So that's a really good question. So it's by observing things in the past, and then we use that data to predict in the future. But, fun fact, ancient China, astronomers, one of their big things is to predict things that are gonna happen in the sky, like big monumental things that are gonna happen in the sky. And eclipses are one of those most regular things, right? Some sort of eclipse happens about every 6 months, and a total eclipse happens every about 18 months. So this is one of the big drivers for astronomy as a science happening at all in the history of the world. But in ancient China, there were two astronomers that failed to predict a solar eclipse. Do you know what happened to them? Yeah, they didn't make it. But it's very interesting because they described it as the dragon was eating the sun, which I think is a really wonderful visual of like what an eclipse looks like. Any other questions? No?
Any questions back there? Don't be shy.
She's going to ask another question.
Oh.
I have a clarification.
Clarification.
Did you say that I could take a picture of the eclipse with my phone?
Oh, yes, that is possible.
Without frying the phone or myself?
I would advise putting a solar filter in front of it. So if you take your Eclipse glasses, you can put those in front of your lens. Yeah, I think the app also explains it more. I'm not sure. I think they're mostly concerned about people who are in totality. I don't know if you're headed to totality. But if you want to take pictures of the eclipse with your phone, you totally can do it, but you should put a filter in front of that, and you can use Eclipse glasses like that. And just put it in front of the lens. Done. Bam. You can also use welder's glasses for 14. Yeah, in front. Yeah, no, where the lens is. Yes, like that. Good. If you put it on the screen, it won't help at all.
You don't have your glasses on.
Yeah, but if you get 2 pairs, then you wear one, and then you cut it in half and you give one to your friend, and you can both take pictures. Right? Good stuff. That was actually a thing I knew, but also somebody commented on our Facebook page about that today. So thanks to that person who commented on our Facebook page today. And we do have an article also on our website that just went up. That's tips about photographing the eclipse with your cell phone. So there you go, if you wanted to know that. Yes?
I know the flat earthers are particularly wound up about this.
Uh-huh.
Do you know why? I kind of missed that part. Is they expected to prove something or not prove something?
I haven't been paying much attention to the flat earthers and their feelings about the eclipse. A thing I would like to know from them, this is a personal question I want to know, is if the earth is flat, what's on the other side? I really want to know that. Turtles all the way down. Yes, exactly. That's also a book coming out in the near future, but I'm not going to, it's fine. It's not anything about flat earthers, I don't think. But yeah, I'm not sure. They have very interesting understandings of how the world works. I read a description that was saying that, well, if you flew from the northern hemisphere to the southern hemisphere and you're in a plane, you would be upside down, but you're still right side up. So, but of course, gravity is a point source. So everywhere, you're always standing right side up. But it's fine. It's fine. Gravity is complicated. And we are all attracted to each other by gravity right now. It's just that the Earth is attracting us more.
We have another question from Facebook from Yvonne. What's the duration of time the corona will be visible during the eclipse in southwest North Carolina?
Southwest North Carolina. Okay, that is a great question. So what you're looking for is the duration of totality in southwest North Carolina. So that is in the eclipse path. I don't know that off the top of my head, but what I can tell you is there's a handy widget that I used here on our website. And you can go to exactly where you are on the U.S. You can go to exactly where you are in the United States and see when the start of the partial eclipse, when of the maximum eclipses, when the end of the partial eclipse is, and then you can click through and you get those diagrams that are on the left-hand side, and that'll tell you when totality is from your location. There are also handy maps from NASA that should be able to tell you that, but that's the easiest, most direct thing is that widget, which you can get to by going to skyandtelescope.com, clicking on our part that says 2017 total solar eclipse, and then if you search widget, like Control F widget, it'll bring that up and you can click through. Cool.
It's right about 2.5 minutes there.
2.5 minutes, he says. So about 2.5 minutes. Thank you. Very good. Did you use the widget? Oh, you're going there. Well, good luck. Have fun. Yeah, he's got a question. I like this part. This is the best part. Guys, they're asking so many good questions, especially you guys. Good questions.
Okay. I heard that if you if you're in the path of totality and you're looking towards the west and you're on a mountaintop, you can actually see the shadow approaching at 2,000 miles an hour?
Yeah, it depends where you are on the Earth, right? Because certain parts of it will be closer than other parts when the shadow's falling. So I don't know the exact rate. Certain of those speeds are in an article in our special issue about the eclipse from Sky and Telescope, so you might find it there. I'm not sure exactly where else you'd find it, but yes, you would be able to see it coming across. You'll also be able to see lots of cool things there. You're going to be able to see the diamond ring and Bailey's beads, and then when it's actually totality, you don't even have to wear eclipse glasses. But only then, please, 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 please don't hurt your eyes. Fun fact, your eyeballs, your retinas, do not have nerves in them that sense pain. So you wouldn't know that it hurt. That's why it's so dangerous, because you don't know that you're hurting yourself. Yeah. Oh, she's got a question. Man, so many questions.
So I'm flying from Washington, D.C. to here, 2 o'clock on Monday.
Ooh.
Well, I mean, I didn't plan it that way.
Yeah.
I'm curious, am I going to see something? Is it going to get dark?
It should be a little bit darker. I'm like looking at the map behind you about where Washington, D.C. is. The sky will be a little bit different. If you can figure out where the sun is out the window, you would be able to see it, I think. Yeah, because you'll still be in the shadow. There's actually a fair number of people who are going to try to get on flights that will cross the path of totality, because you'll actually be able to see the shadow going across the Earth. So that's the really, really, really cool part. But I don't know if you'll be able to notice it that markedly when you're only in the penumbra and not the umbra of the eclipse. Yes. Oh. I feel like I'm just making you run. Get your miles in for the day.
So you've mentioned the potential damage to the eyes if you're not looking for these through these glasses, or,
yes,
or your
projection
fancy box
viewing,
or whatever.
Your fingers.
Your fingers,
the ones you have with you.
For the, I'm guessing millions of people who have no clue that they're not supposed to be looking into it. What happens, or what's the potential damage?
Lesions on your eyes, on your retinas. There is the potential, if they look long enough, they can go blind. So it is a very real, very serious thing. Just ask Galileo, right? Because he went blind from staring at the sun. Because he was observing all of the sunspots on the sun and not with the proper protective eyewear. No cereal box for him. But yeah, so but hopefully, so the thing is, if you don't know that it's happening and you're not in the path of totality, you might go through your day and not even notice that it happened. So hopefully this is crazy enough. This is the first time that we've had such a long eclipse across the United States with all of the social media and media in general that we now have. So hopefully this will hit most people via some method.
And so just to clarify for that, the issue is not that it's an eclipse. Anytime looking directly at the sun is dangerous. It's just you tend to look more because it's an eclipse. That
is exactly right. The sun is always bad to look at. But during an eclipse, you want to look at it. Sunrise and sunset, you're not really looking at the whole thing, and it's angled and diffracted and refracted. Yes, so it's that you are overcoming your normal aversion to looking at the sun, and also that part of it is obscured, so you're kind of like, oh, well, it's not as, but it's still really bad. You're still getting lots and lots of energy coming at you that is very damaging to your retinas. So, yes, don't look at the sun unless you have eclipse glasses on, and make sure that they are from a reputable source. AAS put out an article recently. There were people on Amazon who were selling fakes, and they were even putting on the fakes that they had the licensing and had gone through all of the testing. They had not, so please make sure that you check and make sure you got it from a reputable source, which we are. So yours are good. Yes.
Thank you for doing this. You mentioned that the eye doesn't have sensitivity in the back.
Yeah, the retina does not have pain nerves.
Why does it hurt when we look at the sun then?
It's like a natural aversion to it. Yeah, like it's like, oh my gosh, it's bright. I don't want to look at that.
Okay, so it's actually the muscles that are hurting.
Yeah. It's not the retina itself. Here we go. One more, or 7 more. I'm here. I don't know when it closes.
Okay, I'd like to offer some kudos to Amazon. I ordered glasses on Amazon about a month ago.
Yeah.
And about a week ago, I got a note from them saying that the supplier that I purchased from did not provide certification, so they're refunding my money, and I don't have to send it back.
That's wonderful.
So, yay
good
for
job,
them.
Amazon. Yay. Yeah, it is important, and there will be probably reports of hospitalizations of people who get damage to their eyes. So don't be one of those people. Don't be one of those people.
I have a question.
Yes. So many questions.
So my other question is this. All right, we talked about sunrise, because I'm kind of fixated on this. I've learned a lot about sun, by the way,
Oh, good.
in the last, half hour.
Good, yeah.
All right. Question about, all right, so what about a sunset? Can we look at sunsets?
Yeah, so most of the part of the sunset and the sunrise that you're looking at is the pretty colors in the sky anyway. So that part's fine. That's light just being diffracted. That's like looking in other parts, because it's only actually a very small part of the sky that the sun's at, and when it's low along the horizon, it's going through more atmosphere, so it's being scattered more. So yes, you can look at sunrises and sunsets.
Okay, thank you.
Yes. Yes.
Any last few questions?
Oh, more questions. Okay.
So historically speaking, is there a part of the Earth that has never had a solar eclipse?
There are. I don't have the cool map of it. Oh, I wish I had the cool map of it. There's like someplace in Texas that hasn't gotten one. On average, every 365 years where you are will see an eclipse. But that is not true of everywhere. So I think somewhere in Texas was one of those. Oh, total eclipse, I should say. Partial eclipse, I think pretty much everywhere is covered. Yeah, I think so. Yes?
Hi, so aside from the famous example of measurements made about Mercury's orbit that helped confirm Einstein's theory of general relativity, can you give any examples in history of how certain measurements that we could only make during a solar eclipse informed our astronomical or physical knowledge?
Okay, so the only one that's coming to mind right now, although I'm sure there are more, is studying the corona. So we can only study the corona, which is like, it only has the brightness of about a full moon, whereas the sun has much, much, much more brightness. So normally, the regular brightness of the sun completely blows out our ability to see the corona. And that's very interesting to us because that means that we can study the magnetic field of the sun, which is related to sunspots, solar flares, coronal mass ejections, all those really cool things. So the corona is one of the big ones that they like to study during eclipses. But that's the only one I can think of off the top of my head. I'm sure there are more. I got another question.
Why does the sun hurt your eyes so much?
Why does it? Because it's very, 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 very bright. It's very bright. And it's sending lots and lots of energy. So all of life, pretty much, almost all of life on Earth happens because the sunlight comes and hits the Earth, right? And we get energy. Plants get energy from the sun. That's how they grow. People eat plants, and animals eat plants, and people eat animals, and animals eat animals. And so all the energy comes from the sun. That's a lot of energy, right? That like keeps our whole planet nice and warm. We get liquid water because of it. So there's lots and lots of energy coming from it. And so if your eyes look at it, it's really bright and lots of energy coming at it. And a normal defense mechanism is for you to look away. And then sometimes you see spots on your eyes. Don't look at the sun. Don't look at the sun. That's a very good question.
All right, any last questions? No?
If you can, yeah, you can still get glasses. I'm sure there are some around. She's got them over there by the door.
Oh yeah, we have plenty of Eclipse glasses.
Sorry for the folks online.
Oh, do you have a question?
Yeah. Ooh, question. I think it's caught on feetsies.
Thank you.
Do you want to, so they can see you, for the folks at home watching live on Facebook or after the fact?
So, how do the UV or I guess the filters in the glasses work? Are they just UV filters?
They are a broad band of things, but particularly looking at UV and UVB, and they just block out like 99% of the sunlight. So you're only getting like 1% through. It's like welder's goggles. Like, actually, if you have welder's goggles at home that are 14s or higher, you can actually use 12s, but your eyes still think it's bright. So 14 or higher at home, you can use those to watch the eclipse as long as they don't have any like scrapes in them.
Okay.
Yeah, just blocking out all that energy that we're getting from the sun.
So we don't go blind.
So we don't go blind. So we don't get lesions in our eyes. No fun. Don't do that.
No more questions? Oh,
he's got one
more.
See, this is the best. I get so many questions.
Could
My
you
favorite
just
part.
talk just a little bit about how complicated it's going to be to do the
Oh,
Nova?
yes. He wants to know about the logistics of getting the program
Getting it from
live
here to
in
there
6
to there to
hours.
there.
That's a very good question. I don't have the answer
figure
to
out
that,
Monday,
but she
right?
does.
Right. Yeah, we'll figure it out. You know, we haven't really thought about it that much. It's Monday, this is just Wednesday, right?
fine.
What's this, Tuesday?
Yeah,
I don't
it's
even know
fine.
what day it is. You can see how successful we're going to be. Anyway, we have been actually planning this for months. First of all, we had to really plan what we would do. And there was a thought, maybe we should just do a show on the history of eclipses and put it on before the eclipse, so people would be informed by the time the eclipse came. And we thought that was a good idea, but frankly, it kind of seemed kind of tame. I mean, why not do something hard when you could be doing something easy? So, you know, so what we actually did was we have made a full 52-minute show. So if the sun and the moon decide not to cooperate, if the dragon gets the moon before the moon gets to the right place.
Or clouds.
You know, we're sort of okay because we have a 52-minute show. It's actually already in PBS in Washington, ready to be broadcast. What we will do is, so we have crews in Salem, Oregon, we have crews in Casper, Wyoming, we have a crew that's ready to go with NASA on the jets, or we're ready to just get, we have GoPro cameras on both jets, we're ready to get the NASA material when they come down. And we've already identified 8 pieces of the film that need changes. For example, we filmed with Jay Pasakoff from Williams College, who is the foremost authority on solar eclipses, and he's right here in Massachusetts, which is really great. We went with him to the annular eclipse in Argentina. We've done a lot of filming with him, getting his equipment ready, and he has an equipment expert who's at the Dexter School named Ron Dantowitz, and this man has more gizmos to film the eclipse and to look at the eclipse. So we've already done filming with the scientists who will be in Casper at the Southwest Research Institute where they are. We've done filming with the scientists who will be on the NASA jets. And we have these sequences all cut. We have a beginning of the film, we have an end of the film. At the end, we're hoping that about 10 PBS stations will send us material that's mostly from Chicago, Carbondale, Illinois on, because we don't have crews in the eastern part of the country because the chances of weather not being great are greater there. And, you know, we had like a little thing, like a budget, you know, that we had to, so ridiculous, but that's how they restrict us. So we have 8 sections. We've actually already projected what we're going to write for those sections. So Chris Schmidt, who's our senior producer at NOVA, has very carefully mapped this out, and we all have our marching orders in each edit room. All the material will be coming. We've decided what shots we have to replace with day of shots and what shots we can live with. If something happens to the satellite truck and the transmission is doesn't get to us in a timely fashion. And we may not have time to do all that editing, but one thing is sure, the show must go on at 9 o'clock, and we're very lucky, and our engineer, Emmerich, who's the head of engineering at WGBH, is going to see to it. The whole engineering department is totally prepared. We have satellite material coming in. We'll have satellite material going out. We have private room on the internet booked because we think that the internet is going to be a disaster that day. So we've worked it out with the 10 stations how we think we can get this material. But of course, you can't really tell what's going to happen in a case when so many millions of people are going to be really clamoring to see this and to communicate with each other. So, we've tried to provide for every eventuality. And, I'm sure that some things will go wrong and some things that we have not anticipated will go wrong. But, that's what's going to be fun, right? If everything goes according to plan, it's really kind of boring. But we tried to anticipate what we could, and the rest we'll just wing it. And I can tell you there will be a show on the air on Channel 2. We're very fortunate to work at a station that is the major national producer for PBS and that has this incredible equipment so that we can actually broadcast to the nation, which we will be doing right from WGBH Boston. So those are our plans, and we have a lot to do, so keep your fingers crossed for us.
Thank you, Paula. And thank you. And thank you so much to our speaker, Janine.
Thank you.
Who has been really great.
It was a pleasure. It was a pleasure. As I throw my microphone on the ground. It was a pleasure talking to you all. Thank you all for your really good questions.
Thank you. Well, a couple of reminders before we wrap up. Day of the Eclipse will be broadcasting live from our Facebook page, so follow us at Nova PBS if you haven't already. It'll be hosted by journalist Miles O'Brien and astrophysicist Jason Collerai. And again, they'll be broadcasting from Idaho. And if you guys don't know yet, we're going to be having a show on Monday night, 9 p.m. PBS. The Facebook Live starts at 12 o'clock on the East Coast. Specifically 12:10 if you don't want to wait 10 minutes, but 12:10. And thank you all for coming tonight. We'll be back here next month on September 19th with Ron Dantowitz, who's also a solar eclipse expert who works with Jay Pasakoff, and I believe he's in the show as well. And hopefully he'll be able to share some of the findings from the solar eclipse. So please come back next month. And if you aren't already, follow us at Cafe Sci Boston on Facebook and Twitter. And have a great night, everyone. Thanks for coming.